Hey, today I will show you how you can build this kind of stylized stone stairs that will be fully editable. Here you can change the length, the width, or the steepness. All the stones and all the steps are built automatically. The height and the amount of steps as well are just computed by simple relationship between the parameters. So let's get into it. So let's start with our profile line, and we will use here set the vector direction to Z, and here we'll crank up the length to 3. We need some points to copy the steps, and to make it procedural, so once we change the length, we want the points to be updated. So we will here copy the parameter, then here we will paste relative reference. So now we have a link between the two, but here we just have 1 point per unit basically. So here if I crank up to 5, I get 5 points, 0 because it stops at 0. So if I want more points, I will multiply this by the amount of basically point I want per meter. We will multiply this. So this time basically I get 3 points per meter per unit. If I change the length, I get the points that are updated accordingly. Second thing, we want here a control of the steepness. So here we just have to change the direction, the Y direction, to make it more steep. We'll stay with 0.5 for the moment. We have the profile. So now we want the step line. We will create another line, template the first one by clicking here to see it, and I want this line to be oriented. Let me check here. Crank up the gnome size here so we can better see the axis. So here I want this to be aligned with the x-axis, so I will here type 0 in Y and 1 in X, and basically this is our base setup, and we will use a copy to point to copy our steps on the line, on the profile line. And we will as well here use the length, copy the length and paste it and multiply by the number of step we want per unit. But here everything is very even, so I got the same structure that is repeated over and over. So I want to add some jitter. And here I will use the jitter only on the x-axis. So I will reduce here and reduce the amount. But basically I don't want the tips to be affected by the jitter. So I will use a group. I will group them with a range, because I want it to be procedural. I don't want to select manually, so I want Houdini to select the tips for me. So I use a range node, call it tips, make it run over the points, and I will use start and end point, 1 in start, 1 in end. But here I want to invert, because here I got it excludes the points of the tips. So I want to invert the range to get only the tip points. And even if I change the point count, the tips will be always selected. So here I reduce a bit the number of points. Okay, so now I got randomness. Every step basically has the same value, but we want to make randomness. So if we add some attributes on the points, I will use an attribute randomized here. But basically the copy point takes some standard Houdini attributes like p-scale, but here I want to drive the values. Here I want to change the seed for each point. So I will use a for each point loop here for each point and put the copy to point inside the loop. And what I will be able to do with this setup, I will be able to create an attribute here, then create an expression in my attribute, in my point jitter, to read the attribute. Basically for each point that comes through the loop, we will be able to read its value. So here, first things first, we need to create the attribute. Here you can see by default it creates a CD attribute, but I want to create my custom attribute. So on the points, so here we are on the points. Attribute name, we will create a custom name. I will use rand for randomness. And I just need one dimension because I need a seed. So here the seed is a float. So I need to use a float. You can see in the spreadsheet here that in the points I got a rand attribute now with a different value for each point. And now what we want is to read this value to change the seed here. So to do so, we need to type a bit of code. We want to access the point attribute, so we will use the point expression. The point expression takes a string for the surface node. This is the node we want to read the attribute from. The string attribute, that is the attribute we create here. So the other is just, for the other it's just 0 in this case, so don't worry about it. Just here we will type, we will access a for each begin node because this is the entry of the loop. We will use it as reference, close up, and then just type 0, and here we will type the attribute we want to read, and this is the rand attribute we just created, and type just 0 for the index. Basically, if you click here, we have the rand value that was shown here. So we have our line, we create our attribute, we feed it into a loop, and the for each the copy to point will take the value here on each point. Basically on each point it runs through the loop, and so for each point it reads the values here and feed it to our seed here. And what it does at the end, we have a different value for each one. So now, instead of having the same seed value for each line, we have a different value. So we have each step, each row, each different now. But we have to fix the tips because now our stairs are jaggy. So that's why we created this tip. Because here inside the point jitter, we can access the tip, but if I access the tip, now it applies only on the tips, and that's not what we want. So we will just type an exclamation point here to prevent the tips to be affected by the point jitter. And we will now use this to create the mesh of our stair. So we will copy the line use a copy and transform node to copy the line, and we will copy it here on the z-axis. We'll offset it on the z-axis. Here, if I take just one loop, we will offset it on the z-axis here to create our steps, and to define the offset we need. We need to compute here the length here of the bounding box of the stair and divide it by the amount of steps we have. So to do so, we will use the bbox function. So here we will type bbox and use the z size of the bounding box. So here the bounding box expression takes a surface node, and this is the node we want to read the info from, and the float type, it specifies which bounding box value we want to read. We could as well make a node to make things more clear, and here we will use our stair line to make things clear and more accessible in the expressions. So here I will type stair line, and we want to use the z size of the bounding box. So basically I offset it by the size of the bounding box, so it's way too much. We want to divide it, copy parameter, we will copy the parameter here, and just here we will divide it by the number of steps. So we will pass the reference here, and now you see we now have the length of each step. So the next step is we will use a skin node. Basically the skin node will take two lines and draw a mesh between those two lines, and this way we have the basic row. And then use a poly extrude to separate, because we want to separate all the steps, because actually it's one plane mesh and we want to separate them. We could as well run through a loop. Here a simple way in just one node is to use the poly extrude to use individual elements and use a very slight a very small amount of inset. Here you can see I inset the points, and you have to uncheck the sides, so the out sides, to make separate piece for each stone. I will reduce the amount, and then we will poly extrude. This time we will poly extrude everything, and don't forget to check the output back to get the full piece. And this time we want the height to be driven by the bounding box as well, because here if I change the settings here, it's not procedural yet. To make it work, we have to use the same trick that we use here. We will use the bounding box, so we can copy it, just copy it to avoid having typing it again, but we will change the values. Here we will still use the stair line, but this time we will use the y-axis. We will have to get the height, so we use the bounding box divided by the amount of steps. So copy the parameter. Oh, I should have made, yes, you can say, just use the full here, full same, just by changing the y, and there we go. But you can see I got a little gap between my steps. It's because I divided by the point count, but in fact here you can see that I got 12 points, but in fact I got only 11 steps, because here I got 11 segments. So I got to get the segment count, I got to subtract 1 from the point count. So here, just sometimes it's a bit tricky to write some code here in the expression in this window, so you can use a shortcut that it's Alt-E to open an editor to make it easy to edit your code. So basically we have to use the points here, we have the point count here, and we have to subtract 1 to the count to make it work, but we have to make some parentheses here, because otherwise, apply, yes. The division will be computed first, and then we will make -1 after all. So, but we need to compute this before this, so we need to enclose this in parentheses and make the same, just the same for the other, and get the bounding box, then divide by the point count -1, and there we go. We have now perfect alignment and no gaps at all. But it's a bit too much perfect. If we want a bit of overlap, we can just after this multiply the result by 1.2 or 1.1 to add a bit of overlap between the rows. And there we go. We have our structure, and everything is procedural now, because we can change the length or change the width and the steepness as well, and everything will update automatically. Yes, I think it could be okay for one video. I will make another for the second part, where I will run into a second loop to detail each stone. If you have any question, drop a comment below, and if you like it, yeah, subscribe to the channel and stay tuned for other videos.